I will share my screen and I will ask everybody to turn off their camera and also the micro. And I think the important thing is now also that you know that this will be recorded. This session will be recorded. So if you don't want to, one moment, this doesn't work. If you don't want to be now it doesn't work. Do you see? Yes, you see my screen, right? I will show you the presentation. So the important thing now is that you know that this session will be recorded, and if you don't like to be visible or heard, then you have just not to use your video and not your micro. And while the others speak, we ask you not to turn on your micro and the video. So this is a session about IADOPT working group, interoperability of observable property description. And we are 4 chairs. 3 of us will present today. They will give a short overview what is going to happen in the next 90 minutes. So I will give you a short introduction. Afterwards, Johannes Petersal will talk about the importance of semantic interoperability in the ELTER research infrastructure. Then Maria Stoika will continue to talk about the methodology of the IADOPT working group for 10 minutes. And I will then talk about objectives and the design of the IADOPT framework. And followed by Gwen Moncoiffé, talking about the IADOPT framework using examples of essential climate and essential biodiversity variables. And then we will have around 40 minutes discussion about the proposed framework with some questions that we also prepared. So this working group has the motivation to address the interoperability of the FAIR data management. And my personal motivation is comes from my responsibility or task to coordinate ENFTES, the environmental thesaurus. That's a thesaurus for the ELTER research infrastructure, where I had the task to gather variables for the research infrastructure, and I found it really hard to do this in a coherent way. And I looked around how other research infrastructures are doing this, and I found a great heterogeneity in doing this, and I thought it would be really necessary to work together with others on this topic. So this working group is gathering terminology managers and data center managers from different parts of the world, trying to do the same thing. And we are aiming to build a conceptual framework to support interoperability between existing terminologies for these variables, and to address a broad range of known user requirements, and to promote the use of FAIR terminologies to annotate research with this framework. And this work started already 3 years ago, 2018. And we had already 5 different official RDA events, and this is the 6th one. So we are in the last part of the working group, last phase of the working group. We have still 2 months to go. And we had 6 tasks in total. So we started to collect user stories from the community and to formalize them into use cases. We did a survey on observation-centric terminologies. We derived use case requirements and analyzed semantic representations of variables against the requirements. And the last 4 months, we developed this interoperability framework we are going to present. In the last 2 months, we will check out how to map this framework to local approaches on data annotation, and see how we can implement this framework. And now I give over to Johannes Petersaal. Johannes Petersaal is from the ELTA Research Infrastructure. And I give over to you, Johannes. I should switch off now.
Yeah, and just say next when you are, moving the slides. I'm trying to give you a short overview, and thanks for the invitation to being part of the iAdopt workshop at the RDA, because it's really a great opportunity. Basically, I want to talk about interoperability issues, but not only, because it's always important to understand also the context of the things we are doing in LTR and trying to implement the ELTA information system, where interoperability and integrating data from a wide range of resources is quite important. And where we think also iAdopt is a very important step towards this. And working together with Barbara is really great. We started this work with Morris. There was a monitoring and research information system. There was Seronto going on in the Alternet project, where Barbara also took very important parts. And also parts of it are included, I think, in the work now. And so we are going on. We are still on the way, so we haven't finalized it. Can you go to the next? Basically, I want to put it in 3 parts. The one is to give you the background, ELTA in a nutshell, just to tell you about what ELTA is. It's an emerging research infrastructure, which is now in the phase of implementing. Then have some words on the information architecture, and then about challenges and outlook. Next. In order to address the effects of environmental change on ecosystem, or to assess the effects of policies on how systems are improved, it's important to have an integrated view on an ecosystem and look on the different compartments. Next. So you can just click through. And it's basically similar to others. One again is to have a look on all the input paths of material into the system. Look what is going out there, to assess the environmental change, to look on ecosystem processes and functions. And next, have a look on the main drivers of change, and having a look on how this is affected. By doing this, you have to look simultaneously on the different processes which are going on, and basically that is what makes ELTA a bit complex, both in terms of the observations, but also in terms of the data which are gathered. Next. ELTA is a site-based long-term monitoring. Next slide. It's a site-based long-term monitoring and observation system, focusing on a whole system approach and covering a wide range of biogeographic regions in Europe. So it goes from basically Finland, Sweden, down to Israel. And also is covering a broad range of ecosystem types, from transitional waters to aquatic ecosystems, terrestrial ecosystems like grasslands, woodlands, but also urban areas we are addressing. ELTA is focusing on the different components of the life-supporting systems, ranging from the atmosphere down to the geosphere. And what is most important is ELTA is also including the socio-ecological systems, so addressing the human environment interaction into the analysis we are doing. And what ELTA tries to do is to address the key drivers of change for these major European ecosystems and socio-ecological systems, and analyze how these changes are affecting ecosystem functions, biodiversity, and ecosystem services, which are the basis of human life being and also being of benefit of the for the communities. ELTA is building up upon the legacy of about 450 sites in Europe and about 35 LTSCR platforms addressing the different aspects of the ecosystems, and it aims to provide central services, which is site access, but also, and that's more important, I think, in this context, to harmonized, quality-assured long-term data, which can be used for different scientific purposes, but also for policy assessment. Next. Along with the ELTA research infrastructure, a number of scientific concepts or overarching scientific questions were addressed, which are currently also being conducted in the ELTA Plus and ELTA PPP project, trying to show how ELTA really could improve and benefit to the scientific analysis on a European scale, which ranges from biodiversity and biodiversity loss and land use change to effects of climate change on ecosystems, ecosystem services, aspects of eutrophication, pollution, and the nitrogen cycle in the system, but also addressing hydrology, and then focusing also on socio-ecological questions like land use and land use change. This is also related to a number of, so the presentation is gone.
Yeah, sorry, I'm coming.
To a number of European scale policies where these research infrastructures, where ELTA is just one of them. ICOS, for example, is another important one with focus on greenhouse gases, is also focusing. Next. ELTA tries, and there it comes to the already standardization, tries to harmonize the efforts in trying to standardize monitoring parameters across the sites and selecting a core set of variables which are simultaneously monitored at the different sites. And currently we are having a list of 170 sites. But we must say that one ELTA sites, for example, like Observable, the one we are running, they are measuring over 600 variables on the biotic and abiotic environment. Next. The ELTA data services is a very important part for a research infrastructure, and this is within the current projects is going to build. We are building on a number of different tools which are now integrated to each other, where semantics plays an important role in many of these components. We have the TIMES SDR registry of long-term monitoring sites, which is also used beyond the ELTA network itself. We have the digital asset registry using also, like, for example, EMFTES as a central catalog to document data resulting from the ELTA research infrastructure, which are these data products, but also referencing to data which are gathered from the different sites about the discovery portal, and also providing data labs as an environment to develop commonly and collaboratively workflows doing analysis and using ELTA data. EMFDES is a very important part in that, used for, at the moment, for annotating the keywords, but also try, for example, in ELTA DIP to harmonize parameter namings across the different data providers and metadata providers, which is a quite tedious work to be done. And this is also what we are looking forward into the results from the IADOPT working group on how this could be implemented into the ELTA infrastructure. Next. What are the biggest challenges we are facing when talking about interoperability in the frame of ELTA? It's for sure, at the beginning, it's the broad scientific scope, because basically we are addressing every single compartment in an ecosystem. So that is really from social systems with citizen science data down to abiotic heterogeneity and biotic diversity for all different community or species groups, and also this broad range of ecosystem types. We are dealing also with a quite heterogeneity of input data, which specifically is an aspect we have to deal is the integration of legacy data, which are not collected due to standardized procedures or using common vocabularies or even vocabularies which are shared. So this also needs to be taken into account. It needs to be augmented or integrated with data which are collected now. It's difficult to agree on common terminologies, so that's a quite tedious process. We tried several times, and so we have to go through that, and it's now in the current ELTA Plus project, this aspect also will be addressed, and there is also a lack of applications and tools at the moment we are seeing to fully integrate semantics into the workflows of ELTA. So that is also a subject we are going to work on in the ELTA Plus project. Next. So how do we see this link from ELTA to IADOPT? So what are the use cases we are focusing on? So and where we use semantics. So the clear one is documentation of sites, observations, instruments, and resulting data sets. So that's mainly about tagging or annotating the information, where also for the retrieval, it would be good to have a common vocabulary, which we are using, and I come to that. And another one is on the harmonization of variable names across the different data providers, because they are using different standards, they have a different history, they're coming from different communities, and what we need to have is a common framework to do that. Moreover, also to map this input data into the standard observations, where it's quite important to not only have the name of a single variable, but also to know, for example, in which ecosystem compartment or media it was measured, what was the property measured, and so on. Currently, we are using EMFDES as the main semantic backbone, which is the core vocabulary of ELTA, which includes variable names, properties, media, ecosystem types. So it has a quite broad cover. But there are also limitations where we are looking on other vocabularies. What we are lacking at the moment is the semantic relation between the different concepts to enable targeted information retrieval, for example, to retrieve what parameter or what observations are, for example, done in a certain media. And this is what we are closely looking at, what iAdopt is doing, and try to implement and incorporate that into the current projects which work towards the establishment of the ELTA array. Next. What is important, and that's mostly at the end of every ELTA presentation, is an important sentence. I think Michael Myrtle, head of ELTA, brought that up. It's an African proverb. So if you want to go fast, go alone. If you want to go far, go together. And that's more. It's very important also in the in the current work we are doing, because this kind of effort, as it is very time-consuming, can only be done together and needs to be done together in order also to ensure not only interoperability within one research infrastructure, but to ensure also the interoperability across the different research infrastructures as they are closely interconnected and co-located in a way. So thanks for giving me the time to give you a short overview on the ELTA project, and I'm looking forward to the workshop.
Thank you very much, Johannes. I think it was very interesting what you presented, and I think we can allow to have 1 or 2 questions directed to Johannes if they pop up immediately. Otherwise, we will postpone that to the discussion part. Maria or Gwen or Alison, is there any question in the chat? I can see it.
Question from Maggie. Johannes, when you say that agreeing on common terminologies is difficult, can you see it? Can you read it?
Yeah, it's just gone again. So it was
hold
on
on.
the screen.
Yeah.
It's
coming again.
Johannes, go ahead.
But if primary related to semantic differences, or no, it's basically at the moment it's bringing together the different communities which are part of the ELTA consortium and implementing it into the workflows we have setting up. And it's basically what we learned also with EMFTES. It's quite time-consuming if you focus on aspects which are not completely covering the aspects you are trying to do. It's not difficult. It's tedious. Let's put it like that.
Thank you, Johannes.
Yeah.
I think we should go on with Maria Stoica presenting the iAdopt methodology.
Okay. Barbara, Diana was saying that if you switch your microphone off, you will not be seen on the screen. I don't know if you've seen that.
Yeah. I can try. No, I cannot see anything what you write. So, and what about the Q&A? The questions, do they pop up over the screen so that they hinder to see the slides? Do you know that? Hello?
Yes, I know that. This is why I said, you might want to take questions at the end of the talk, because then
I think it's better.
Yeah.
I think it's better. So should we ask not to ask now, or what?
It is up to you. You can take questions after every talk, just like you did with the previous talk, or you can take questions at the end of all the talks. It's up to you.
But isn't it possible to put the questions in the chat without letting them pop? No.
Yeah, Barbara, it popped up because I actually activated it. So it's okay. People can ask questions, and then we will deal with it after the talk. Yeah.
Okay, so I should switch off my micro, right?
If it works. If not, please don't worry. It's okay. We can see the slides. So don't worry too much. Yeah.
So I will go give over to Maria now, okay, and share the screen.
Okay, that's great. Can everyone hear me okay? Okay, great. So I'm just going to briefly do a high-level workflow overview of our methodology over the last couple of years. And each one of these steps that I'm going to go through took several weeks up to several months. So if you have any more questions about specific details, you can put them in the chat. So the first step that we did for our methodology was to collect user stories. And next slide. The way we did this was by using our GitHub page to allow community members to open issues. And we provided a template where the community member could provide their role as well as what they would like to do, some kind of task that they wanted to accomplish, and the reason for wanting to accomplish that task, as well as providing their domain of interest and any additional information. And here you can see an example for using BODC and CF standard names terms interchangeably. The next step was, once we had our user stories, we organized these user stories and we grouped them into 4 major categories of use cases. And for each one of these use cases, we identified functional requirements for our future framework. Next slide. And so the 4 use case groups that we had were first terminology generation and management, which basically covered the gathering and organization of terminologies, encoding these semantically and implementing search algorithms. And the resulting framework requirement would be that components are able to categorize and cover the full terminology landscape in our domains of interest that were present in all of the relevant terminologies. The second use case group was resource annotation, which involved tasks such as automated and semi-automated annotation tools and services for resources. And the resulting framework requirements were that the components should be flexible enough to be applied to different forms and representations of the relevant terminologies. Our third use case group was data discovery and exploration, which involves keyword and faceted semantic data searching. And as a result, our framework needs to be able to enable terminology mapping through synonyms or alt labels or other kinds of mechanisms, and to provide meaningful component categorizations. The last use case group is data manipulation and integration. And this involves tasks such as combining and transforming data sets from various sources and from different presentations and formats. And the framework requirement that resulted out of that is that we needed to use just the minimum number of highly generic essential components that could apply across the wide range of applications and terminologies that we needed to address, and essentially not over-define our framework. Next. The next step was to gather and study existing relevant conceptual models and terminologies to determine the more specific information requirements. And again, we turned to our community for this. And next slide. And in order to do this, we asked our community to populate a spreadsheet. And if you look directly at the presentation, which I think we will provide, you can click that link there and it'll take you to this spreadsheet, and it'll show you all the different terminologies and conceptual models that we gathered, as well as are based on our review of the content of these terminologies, what kinds of components each terminology has. Next slide. So by the end, we cataloged around 100 conceptual models and terminologies. And we found that the most common components that occurred frequently in these terminologies were objects, and these involved either the objects that are of interest for a measurement or contextual objects, as well as properties and quantities. We also found, specifically for objects, we found that the matrix or medium occurred quite frequently. And we also found constraints, and as well as methodology components. And although this terminology was present, as you see it indexed above, they were not always decomposed and atomized at this level. So sometimes they were, the components were found in combination. Next slide. And so what we'll be covering for the rest of the presentation is this next step, which was that from all of this gathered functional and information requirements that we determined, we then moved on to define and iteratively refine the interoperability framework based on the use cases and feedback from the community. Yeah, I think that's it. Yeah.
Can you hear me again?
Yes.
Yes. Thank you very much, Maria. Are there any immediate questions to her? Or should we just go on with the presentation? I don't see anything at the Q&A. Yeah, okay. So I think we can just go on with the presentation, and I will continue to talk about the objectives of the IADOP framework. So I hope you can hear me well and you can see the presentation again. So the focus and scope of the IADOP framework are variables. We think that variable names pop up everywhere, but they are often quite fuzzy in their description. A variable can be represented by a combination of descriptive components, giving meaning to the value that is derived from different kinds of acquisition events, like an observation, a measurement, a simulation, or calculation. So the concept variable in IADOP represents what has been observed independently of where, how, and when the data acquisition took place. Yes, probably those that followed our activities for a longer time, they wonder now why we call it variable and not observable property. So when I talk about variable, I mean also observable properties, but in the framework, we use the term variable also because it is more appropriate to address all these different data acquisition types, like simulation calculations too, and because the observable property is a concept used in SOSA and a bit in a different way, and we found it really difficult to use it again in a framework that will be then conceptualized in our ontology, and therefore we opt to use this term variable. Also important to know is that we are just supporting classification of types, not of actual measurements. So a value can be described with a variable because this variable can also be used in another measurement. So it's defined independently of where, how, and when. That's really important to know. So the challenge we address here is that we found that there are huge collections of variables out there, and also a lot of vocabularies describing these variables. But this is probably not an issue that will always happen. But the issue that we see is that they are not mapped to each other because they are really complicated sometimes, and they are described very differently at different levels of granularity, as you can see. So wind speed or speed of wind, yeah, it is easy to map this, but we don't have only such easy ones. We have also like examples like molar concentration of atomic nitrogen in Earth's atmosphere. So we can find that also very simplified, like a nitrogen concentration, which does not say a lot about the context. So we want to address this challenge with with the IADOPT framework. So analyzing this a little bit more in detail. Let's say we have this observation: monthly mean dissolved lead in ppb in water taken from the River Thames by sampling. We have first to just look at the yellow box here in the middle, which is the observed variable. So the monthly mean dissolved lead ppb in water. We don't consider the River Thames, which is a feature of interest, which is a real feature in nature. So we are not addressing this. That's the where, and we are not also addressing the how, the process, the sampling procedure or the measurement procedure. This is really kept outside the IADOPT framework. But we look at the yellow box, and we think it is necessary to decompose this in the main components, which could be the monthly mean, dissolved lead concentration, water, ppb. And what we want to do is to associate the for each of these boxes terms from other terminologies. There is a micro on from somebody else. If you could put that, shut this down, please. Thank you. So, yeah.
Sorry, Barbara. The slides are not changing for me. I don't know about the others, but I'm still on your IADOPT framework focus and scope slide.
Yes, is this for everybody so? Hello, can somebody say something?
It's
No,
working.
it seems to be working here.
Yeah.
Okay, right. Okay, sorry for the interruption.
No problem.
It's a problem with me. Okay.
Yeah. So for each of the boxes, we also want to find terms from existing SCOS vocabularies, but also ontologies that we can use to describe each of these terms or components. What we also found out is that the ppb, which is not really a unit, it's just parts per billion, but this is not a part of the observable property or the variable itself. So it is important to address in which unit quantifiable property is addressed, but it is part of the value and not the property. It's not part of a variable because a variable can be expressed in different units. So it is the value that should come together with the variable description, also with the unit. So we found out that we have to keep these units out of the framework itself. So what we want to achieve is to enable semantically precise and fair descriptions of observed, measured, modeled, simulated, whatever variables used primarily in environmental research like biodiversity climatology. But this is just now, so the focus is at the moment in the environmental research. If this works in this, which is already quite broad as a science and sub domains. If it works here, then probably it works also in other research domains. Then we want to decompose this description into atomic components that are then easier to map and reuse. And then we are developing this framework iteratively. So its components are refined by reviewing current annotation practices and by validating against a set of requirements from real-world use cases, as you have heard before by Maria. And we use examples where each component is linked to concepts from existing vocabularies. And we test this IADOP framework also for interoperability between a number of existing terminologies. So this is what we are doing within the IADOP working group. And one of the outcomes will also be guidelines how to address this and how to implement this for scarce vocabularies. One result will be to label variables or use variables together with scarce extended relations to map to the components that we propose in the framework. So to help aligning across vocabularies. And what we also want to do is to provide best practices to address different use cases and varying degrees of complexities, detecting patterns of description. And in an associated effort, VG members, but it's me, I will formalize this framework into an ontology because I'm writing a PhD on this topic. And another PhD supervised by a member of the core group of IADOP will also develop a context-sensitive, user-friendly data annotation tool based on this ontology, so that this description, so the annotation of results, value results, can be done with these fair terminologies based on the IADOP framework. So now this is just graphically what I already tried to explain. What we try to find out are the different components of the IADOP framework. We then compose or make a model out of your framework, providing relationships between these components. I will go into detail a little bit later. We will then find out for each component also possible or suitable terminologies to be reused, and this will be growing resources, but we will do it over those that we have already gathered in our catalog for our terminologies from our survey. And then we will also check if the terminology that we have in our terminologies, in our vocabularies, like ENFDES and NERC and ANAITES and whoever wants to join this, that we try to really make our vocabulary map to each other, so that habitat in PUDC means habitat also in ENFDES. But we have all these terms already, but we have not really mapped them, all of them, but we will continue to do that. And when this is done, we can make sure that the variable, the controlled lists in the different terminologies will have variables that are mapped to each other, because using the IADOP framework makes it then easier, because each variable is then linked to atomized terms that they themselves are also mapped to each other. So one other output is also that we will find out patterns of reusable variable categories, because they will always use the same components, type of components. Think about amount of substance. It will be the same for nitrogen than for carbon. You will always use the same type of descriptive components. Or abundance of species, it's the same. And this will help also to provide these guidelines. And based on this, it will be possible to build an ontology and derive shackle rules that can be used in a service, in an annotation service. let's say in 1 year or two, we will have something, or also earlier, we will have an IADOPT service for annotating variables. And a researcher then just can type in natural language what he or she is observing, and the system will help to identify the right variable descriptions. So how does the framework then looks like? This is just to give you an idea how the Padlet pictures can be read here. If you see just an arrow without a label, it means that there is a relationship of a subclass. And if you see a label on the arrow, then this is a relation, and it is normally without information about the cardinality, but if a cardinality is given, then it's not one-to-one. So this is the whole framework. It is more easy than many of you already might know, because we worked a lot in the last months, and we had it much more extensive with lots of more boxes. Now we reduce it again to the most important ones. So we think that a variable has at least one property and one object of interest. The property is a quality of an object of interest, so the property and the object of interest are, or the property is dependent of the object of interest and describes a characteristic of the object of interest. And but the variable can also have additional components included. Apart from the object of interest, there could also be involved a matrix and the context object. And let's discuss and look at one example. That's the concentration of endosulfan sulfate in the flesh of Ostrea edulis, expressed per unit wet weight. We can see this example here. So you see under the variable, you see the whole label for that for that variable. So it's quite a long sentence to address what it is about. And this can be decomposed, as I said, in a property, which is the concentration per unit mass in this case, which is a property of the object of interest endosulfan sulfate. So the endosulfan sulfate is measured in the flesh of, and that's the matrix, of a context object, that's Ostrea edulis, that's the species. And it's also important to know that it is here the wet flesh and not the dry flesh that is measured here. That this is a condition that has to be considered in this measurement. So the concentration is about the endosulfan sulfate in the flesh, in the wet flesh of this species. As I said, not only the property is important and the object of interest, but also other components. And in this case, we use all these parts of the IADOPT framework, all these components. And these components, here you see them. The green parts here, context, object, matrix, and object of interest, they are all observed entity roles. And these entity roles can be assumed by entities. And entities can be everything which is living or not living, so biological or non-biological. And they can have different roles in the description of a variable. So an object of interest is the target, observation target for which the property is being observed. So in the endosulfan in this example that I mentioned before, it is endosulfan sulfate. So this is what is being observed because we want to know the concentration of this substance. And the context object is the Ostrea edulis, because it gives an additional descriptive information about the object of interest. So it's it's the information that the concentration of endosulfan sulfate is studied in the flesh of the Ostrea edulis. And the matrix is the material context, the surrounding context, material of the object of interest. So the flesh, it is in the flesh that you are going to measure this. And the constraint is refraining the condition of the entity. In this case, it's the flesh. So you can see it here again. A constraint can be applied to any of the observed entity roles, to the context object, to the matrix, and to the object of interest. In this example, it is in the matrix, so it's the matrix constraint. And it is important that the flesh is wet and not dried. And as I said, entities can be everything that can be observed, any object out there. Then here you see the context information. So the blue boxes that you see here are outside of the IODOP framework, but they give the context to how the IODOP framework can be applied to, for example, observation and measurement, or BOE, or any other observation model. So therefore, I also did not really use the term observation and measurement, because it should also be possible to connect this to any other type of data acquisition. It could be also a simulation, a calculation, but always you have a result value out of that process, out of that activity. And you have, if it is a numerical value, you have very often an associated unit. And sometimes you have also a modifier, like a statistical modifier, giving information about is it a mean value or a standard deviation. And if it is also quantitative value and you have a unit for it, then this unit must be consistent with the dimension vector. And this is also connected to the quantity type of a property. So a quantity type can be the way how to express a property. Like height, speed, concentration, or density is a quantity type. A quality type would be something that you can only address with qualitative controlled lists, nominal or ordinal lists, like color, taxon, or presence of species. Yeah, and you can find all these different definitions in our documentation, and here you have the link, and then see yourself in detail. So just to give you a last outlook how this can be applied, you can see here that the same example can be expressed in SCOS using extended SCOS relations, like has property, has object of interest, and has matrix, and has constraint, and context object. And this links to existing terminology. If you can also try this out yourself. There's all these slides are connected with existing links online. Here, another example, a bit more easier one from the biodiversity domain, the shape of an organism, in this case of Limnococcus limnaticus. The property here is the shape. The object of interest is an organism. Yeah, because you are looking at the individuals of this species, and the species is the Limnococcus limnaticus, which links directly to the scientific name, and also to the repository. I think that's worms in this case, where this species is described in more depth. So thank you. Yeah, and here you see how this can be used in a SCOS implementation. And I think this is all for giving you the insight on the framework itself. And now Gwen will address this from a very specific domain, the marine domain. Thank you very much. when I give you the word and I mute myself.
Sorry, I'm still having problem with, I can't see your slides shifting, so I've refreshed several times, it still gets stuck. So maybe could you stop sharing and maybe I'll try and share. Did you hear me, Barbara?
So
I can't hear you.
Yes, now you can hear me, right?
Yeah, I think the solution is for you to stop sharing because I'm stuck and it's just your presentation doesn't shift, and I'm going to try and share. Can you see? Can you see my presentation?
I can see it.
No,
Okay,
not
good.
yet.
Yeah.
I don't know.
No, that's my face. Not yet. You know which button
Not
to
yet?
press?
Oh, share. Sorry about that. Can you see it now?
Now it works. Yeah, now it works. Yes.
Right, and I hide that. Right. So, I mean, initially, I had planned to talk about the interoperability framework and look at examples from essential climate and essential biodiversity variables. But the way things were going, we decided to just focus on a very simple example. And here I'm going to talk about how we can address the issue of semantic alignment and data integration, which was two of the use cases that were presented to us. And I will take an example from the marine domain. So those were the six of the many user stories that were submitted to us. And I selected the six that actually mentioned semantic alignment. And three of them, which one came from a researcher looking at long time series data and trying to find, to perform a semantic search across multiple vocabularies. And the other one came from a data manager who wanted to find a way to exchange data between a repository using the BODC parameter usage vocabulary and the CF standard names. And the other one was from a terminology provider who was trying to find an easy way to manage terminologies and ensure that there were interoperability between multiple sources. So in the marine domain, we have three parameter labeling schemes that are well used. The first one is the CF standard names that is used by the CF community. The second one is a BODC parameter usage vocabulary used by the C.NET community and OBIS as well. And the OBIS being the Ocean Biodiversity Information System. And the third one is the ICIS param vocabulary, which is used by monitoring agencies in Europe and other countries of the North Atlantic. So we do need, in order to get access to data, we do need to use control vocabularies to discover and to tag the data. Here I present an example of the GOOS essential ocean variables. And I will just select one simple example from those many EOVs, and it is oxygen. So ideally, being a user, you want to be able to select the EOV oxygen and to interrogate different data repositories, distributed data repositories, and be able to work with the data in an integrated fashion. However, many of those repositories, they do use structured vocabularies to describe the variables, and those descriptions are machine readable. However, are they interoperable? And the answer is no. And here, looking at searching for dissolved oxygen in the CF standard names, in the BODC PUVs, and in the ICIS param, I'm able, as a human being, to find terms that match what I was looking for. but they came up with very, very different labels. Some, like CF standard name, mole concentration of dissolved molecular oxygen in seawater. In the BODC PUV, concentration of oxygen, O2 per unit volume of water body, dissolved plus reactive particulate phase. And in the ICIS param, dissolved oxygen. So all those labels are very different, even though some of them are very detailed and structured. So are they the same? So this is where the IADOP framework comes into play, because really by actually mapping each of those concepts to the agreed components of the IADOP interoperative framework, we can say that for each of those, the property is concentration. For the object of interest is oxygen or deoxygen, in this case. The matrix is the water body, and the constraint, there is a constraint on the fact that this oxygen is dissolved in the water. So then if we go back to our EOV concept oxygen, in order to be able to discover data associated with this EOV, we need to do the same with the EOV oxygen and map this EOV to those components of the framework. And in addition to that, we need to consider the units and dimension, which would enable us to make conversions between data units. So as an example of implementation, if we go back to the example to the situation I described earlier, if you are a user looking for an EOV oxygen, you may be able to select your EOV from a drop-down list. Then there's a series of semantic rules that can be applied in order to run, for example, a Sparkle query that would come up with a list of valid variables to their URIs, as well as, the variable names as URIs, as well as mappings between those different variables. And this can then be sent to a query engine, a broker, or an integrator that can then be interfaced to the different repositories, and you start having interoperability between data coming from those different systems. So this is the end of my presentation. So if you have any question before we start the discussion.
I will share again my screen. So
I'm sharing.
So I have to go through it again. Are there any questions? We have. Can we also share the presentation? Can anybody of you, I don't know, Circo, Alison, share the link in the chat so that people can have all the links? What you can see here is that we have a link to the documentation and the Padlet. Is there any question?
Can you see?
Should we, Barbara, should we go through the Q&A?
Q&A, which one? I have a problem with my computer at the moment.
The questions, do you want the questions on the screen, one by one?
Yeah, I wanted, but I...
Okay, I'll do that. So the first one, Alex says it was for Maria.
Yes, I cannot do anything with my computer. I have to go out and in again. Sorry. It is somehow broken. So you can go through. Now it works. Now it works again. So the questions from the Q&A, yes, please go ahead. Hello?
So I just shared one of the questions that hasn't been answered, which is what is the personnel split between domain specialists and ontologists in iAdopt? And how did you find the interaction?
Okay, should I say something first? I think many of us are modelers, we're semantic experts. The split. The core group, I think all semantic experts. The wider group is a mix. I don't know. Gwen, can you say something?
Sorry, I'm just I'm struggling with my control board. About the split between
modelers and domain experts.
Yeah, there were more modelers at the beginning, but hopefully we'll get the modelers re-engaged.
No, the modelers, the domain scientists, you mean? Yeah.
Yeah, domain scientists. Sorry. Yeah. So.
Okay. Next question.
Should I ask the questions that have already been answered in the Q&A?
No, I think this is okay. So we can go on to present the questions that we have addressed. No, we have something else. The other examples already prepared. I have a problem a little bit with my computer, but I hope that this time it works. I'm sharing, right? So we have presented the chemistry example. And we have also shared the biodiversity example. And now I go on with the Earth observation example. This is an example provided by Xenia. I hear a lot of noise in the background. Can anybody else who is not talking at the moment mute? Yeah, thank you. So this is an example by Xenia I cannot read the name, from Blyforge Eric. And she does this with remote sensing. She is detecting the grass species on a lens parcel. And doing this decomposition with iAdopt, it would be taxonomy detection of a grass species on a land parcel. And grass is the object of interest, land parcel is the matrix. Yeah, the methodology, how you do it, it's outside. It is really outside because this is not part of the iAdopt, but you can see how this would be linked. It would be the procedure linked to the measurement and linked to the result value, and this is linked to the variable. Is there any question to this example? There are questions. I'm trying to read them. There are questions to Gwen. Wondering if there is any progress in having the goose. Can you answer this, Gwen?
Responding to Rena's question.
The goose. Yeah,
I didn't realize it would pop up on your screen, so it was from before. Yeah.
Yeah. Can you answer this?
Yeah, it's done. It's done already.
It's done already. Okay, sorry. Any question to this example that I had before? Otherwise, I show the next example. The life science. I first perhaps the social science example, because it was asked if you are just concentrating on environmental research. Well, not only, also others are interested to use this iAdopt framework. like Peter Mutschke from GESIS. He is wondering if we can also address questions from surveys here. The variable would then be the question: to what extent are you affected by corona measures, for example? So the affectedness would be the property. The object of interest is the person, so who is here affected, and about what is the corona measures. It's a way how you could model this. This is just a starting for this experiment, if it really works for the social sciences. If you have any questions here, can you please interrupt me? You can also use the micro if you want to ask me immediately. And a last example that we tried to model for this presentation is the molecular example from the life sciences. This is presented by Petra den Hoppen, and this is 18S-RNA amplicon nucleotide sequence of picoplankton from vertical profiles of open ocean water. So the property is the nucleotide sequence on 18S-RNA amplicon. The object of interest, the matrix is open water ocean, and the context object is picoplankton. The vertical profiles are certainly outside this IODOP framework, are part of the sampling procedure, which is linked to the observation. I wonder if the amplicon is not also part of the method. So I am not a life scientist, so I have a bit too little knowledge about it. But if there are some life science people present here in the audience, they can really interfere and say something. So I'm not totally sure if this is represented correctly here. If nobody is asking anything about this, I would like to ask your contribution to the next questions that we have prepared in our poster. So Gwen, how did we organize this? Do we want people to answer right now, or to go to the poster and answer there, and then share this with us? I think we have only 15 minutes left. That's a bit a short time.
Except, Barbara, I can see some questions popping up on the screen, but I can't see them. So I don't know. Diana, would you be able to?
Yeah, but these are always the same questions that have already been addressed.
Oh, okay, right.
Yeah. So I don't see any new questions.
Okay, because I can't. I've lost because I had to refresh my screen. So okay, yeah.
So these are the questions that had already been addressed.
Okay.
In that case, there are no new questions.
Okay.
But should we ask now the audience to answer?
I think it would be good if the audience could go to the poster and maybe answer those questions.
But there's a danger that they are locked out and again, and they should go in again. So I'm a bit hesitant how to do this now. And we want them to talk with us and not only to do some work outside. So we can invite you to go to the poster and to answer this, but we want to have some reflections now. You know?
Can I just say that if you click on the poster link, please open it in a new window or a new tab. Otherwise, you'll be kicked out of the session. I'm really sorry. This is not ideal.
Yeah.
Yeah.
Okay. So this The first question that we wanted to ask is about how easy the framework is to understand. So there's one you can also answer here, I think, in this Q&A, and give a number between 1 and 5. 5 is good to understand, it's easy to understand. Or if you really want to say also your opinion on it right now, we would be happy to hear it. Any opinions? Can you write in the chat? There's a chat. Yes, you can ask a question, Alex. Alex Henderson, can you just go ahead?
Hello. So I think it's a nice structure, but I'm not clear on how the on how much you really need to understand it to be able to decipher the variables. So if you've got this variable where you have the RNA amplicon nucleotide sequence of picoplankton, such like, I can understand the diagram and I can see why those were the chosen responses. But if I was given that variable, I think I would have difficulty deciding myself whether something should be a property or a context and such like. So that's why I asked the question about the natural language processing, on whether that sentence would be sort of text mined on my behalf, or whether I, as the researcher, would need to map it myself onto the platform.
Yeah, Alex, that's a good question, because I am not from life sciences and I feel also not very confident with this modeling at the moment. But I must say there are two sides of the medal. There are the terminology providers. They should know what they provide and what they describe, together with the domain scientists on the one part. And so these examples have then to be built together with a domain expert. Yeah, first. And the researcher using this term should know about the research he or she is using, and therefore it is important that this is in the language for the researcher. Yeah, so the variable itself should be descriptive. On one part, you have the possibility to define the variable, yeah, by a natural language text, and then with the links to existing other terms, it becomes also machine readable. So NLP can help, but I'm not sure how far it will help, and this is all something to experiment and to find out. This is now the basis to start doing this work, right? So it is also not the final, so it's probably not the last version of the IADOP framework, but it's the first one that we are going to publish now.
All right, cool. Yeah, I think the examples are very helpful. The difference between a context and a matrix. I can understand it with the chemical in the fish, and I can understand it by reading it, but I have to read it carefully so that I would be able to then apply that. So it's
so we want to provide guidelines for that and to make it very helpful, understandable how to do it, but there's still some challenge, right?
yeah, sure.
So Rolf also mentioned that there is a data curation experts in his facility, and do you want to say something, Rolf?
Yeah, sure, I can speak up. I was the one asking whether this is focused on environmental research, and I come from a completely different area. So I'm a synchrotron light source, and we're having lots of different domains, mostly material sciences and other physical stuff. And It seemed to be very interesting to look into, but I can't possibly say immediately whether we can make use of it or not. We have to discuss it with other experts on our facility.
Yeah, but we are happy to have a telco with your experts and try it through because we have a possibility where you can, in GitHub, where you can just put in your variable example and we try to model it together with you or propose it and come back to you and see how this could work.
Yeah, as I said, I need to discuss it with other people in our facility.
Thank you. We had also the question, if you have any suggestions for improvement. I think you have to really look into this and in more detail also to look into the description. We have here the IODOP framework description with where you have the definition of all the components and how they can be applied, but it's not a guideline, right? So this will follow on the next 2 months. But we are very happy if you can try to connect with us and to give us feedback on this. If you go to the poster link, you can answer them these questions and give us feedback immediately after this poster session, IADOPT session. Yeah, and you can really also go to the poster to vote for it if you find it interesting and an interesting approach. And I really want to say the huge task lies on the terminology developer, terminology provider, and not on the scientist using it. I think the scientist will be helped by this approach to properly describe his or her variable in a fair and machine-readable way. So we are not overloading the scientist here. We are overloading us as terminology providers probably, but we think that once we did this work, it will really be reusable. Any other comments that come from the audience? Yeah.
So you obviously identified a number of terms that match well. What do you do if something doesn't match, where there isn't really an obvious ontology that you're aiming at?
So there are a few, for example, for the quantitative properties, or you will find, for example, QDT, and QDT is really a good resource if you also need units, because it helps to convert units from one unit to the other if you have different variables measured in different units, and therefore, yeah, it would be good to have a certain property there in their vocabulary. And if you don't find it, you have to request to submit this request for a new term to be minted. But you can also do it in other terminologies. You have always this possibility to submit requests. Sometimes this is a tedious and long process. I can only say that we are eager to do some good progress here. And so there is Gwen Moncoffet from the NERC vocabularies, who is also very interested to improve the whole system and to get this done more quickly. And me in ENFDES for ELTER, I will do it also. And others involved here, like from Annotation and so on, from different subdomains, they are doing this on hopefully also based on the outcome of this IADOPT working group. So
that's great.
Yeah, Ulrich is here. Ulrich, can you speak loudly? You ask.
Yes. Yesterday we had the PID for instrument working group, and after my talk about the connection data type registries and linked data, Barbara said essentially that we should think about that. And my question is whether she has any ideas about that, or
Yeah, not yet, Ulrich. I was really a little bit focused now on doing this, on bringing everything together for this session. But I think this is the next step to look into how this connects to other work and how this can be somehow integrated also in the data type registry approach.
Okay, so yeah, perhaps you should invite me to one of the next sessions you have.
Yeah.
And then we can discuss that.
Yeah, I would be really happy to do this.
Okay.
I think the first is always to get our minds clear on what we want to achieve, and how, and if it took quite some months to get this framework at this stage, but now we are quite happy with what we have, and now we can really see how this could match to other work. But we also looked into other approaches, but more from the domain science perspective. And then I also saw there's another group here that is data granularity or something like that I missed this morning, unfortunately. But Maggie probably knows about it. Have you heard about it? There's a new emerging working group on data granularity.
Yes, indeed. I'm a member of it. And I had a presentation today about environment MVRIS and our data, but on the one level higher, so not going into the variables, more than mentioning that, of course, there are also variables that you need to take into account for defining the granularity level. But Ulrich was also in this session, I think.
Okay, so you think it's another level of this?
Yes, but I think it's tied to this, and I think it would be very helpful if we could investigate whether it's useful to have persistent identifiers for the variable definitions, because then we can use those to define the granularity levels.
So Maggie, I'm asking you, are these identifiers that NERC uses in the POF parameter? How is it? Variable descriptions. Gwen, can you tell?
There are URIs, but they are not PIDs as such. Mm-hmm. But I suppose we would need to talk about how to approach that, Maggie.
Yes, but Ulrich's idea about having a type registry would fit into that, because that's enough to have, so to speak, handles for this. You don't need to go all the way and get DOIs or something like that. It's just that you really have a unique and resolvable identifier for these things, because then you can also keep track of versioning if there are changes in the definitions and things like that. So I think it opens up a lot of great things to work on in the coming years.
Yeah, I suppose it links up with the work on fair semantics as well. But I mean, we do have version tracking. We've got the concept level, but the only thing is that we're using URIs instead of using, a particular specific PID kind of system. But I think it does link up with some of the work that is done as part of the fair semantics.
Yeah, so to me, as a complete noob on this, I think that fair semantics and semantics for fair or supporting fair are both equally important.
Mm-hmm. Yes.
And Gwen, a question to you, not Gwen, Maggie, a question to you. You have seen what we have done so far, and you have seen also the progress. Do you think it's now easier to understand? We reduced it to the main, the most important parts.
Yes.
Understandable?
Yes, it's much easier now. And also the more examples that one can compare to, the better. So I'm looking forward to try to do something with ICOS variables now.
Yeah, and I would also be happy to see how we can use that within NRefair and doing perhaps some training on it, because it's not trivial, although it's easier now, but it's still not trivial to understand it. And I think a lot of examples have to be done or described with it to be sure that it works.
Yes, but I really want to congratulate all of you who have been really pushing in this and working in this group. I think this is a very good contribution to the whole puzzle of research data management. So thank you very much.
Yeah, I thank you for your interest. Okay, so we have already reached.
Agree to Maggie with a thank you.
You agree? Okay, thank you, Ross.
Thank you very much.
Gwen, do you say any last words for?
No, just, well, thank you to the audience. Sorry for the small technical problems that we've had along the way. We're having another session on Friday. There's also the poster, so please, continue providing some comments. I think there is possibility of commenting on, well, we've got that questionnaire associated with the poster. And there's also a small text box where you can, provide some suggestions. We've provided links as well to our GitHub, where, again, we've got a repository dedicated to the interoperability framework. If you want to comment on what you've seen so far, or if there's anything that needs clarification or you think we haven't addressed, then we would really, really love to hear from you. So we still have 3 or 4 months to work on the final deliverable for this working group. But yeah, please, get involved and help us make it useful for more people, or for as broad a range of people as possible, of users as possible. Thank you very
much. Yeah. Bye-bye. See you on Friday, some of you, and on the poster. Bye-bye.
Bye-bye.